Today we're going to talk about transition metals. Now, you know many transition metals. They're in the columns 3 through 12 in your periodic table. Metals like gold, silver, copper, iron, all of these are transition metals. But there are some really interesting characteristics about transition metals you may not know. For one thing, they're all ductile. They're also malleable, which means they can be bent into long wires and they can be moved, shaped. They're known very well for conducting electricity and heat, like copper is used in a lot of wiring. And silver is used as solder because it's able to conduct heat so well. Now, they're also known for having valence electrons in more than one of their outer shells, unlike most other conventional metals. Now, they are metals because they're transition metals, which means that they have all the characteristics of metals. They have luster, they're hard, they're not liquids, mostly. We'll learn about that later. Now, transition metals are also known for the fact that they can have different charges. Like there's such things as mercury 1 and mercury 2, which have a charge of +1 or +2, depending on which one it is. So now let's go into depth about some of the more specific elements. Now we're going to talk about mercury. Wait, I need my sunglasses. Mercury is from the ancient Latin word mercurus. Now, mercurus is also the old name for mercury with a charge of +1, or Hg1. Its other old name is mercuric for Hg2, which is mercury with a charge of +2. Now, as you can see, Hg stands for hydrargyrum, which is the ancient Latin word for liquid silver. Now, it's got the atomic number 80, which means it also has 80 protons and 80 electrons. And it's got 160 neutrons. It's an amalgam, which means that it easily forms compounds and alloys with metals, with other transition metals like gold, silver, and copper. Now, it's not found naturally in nature, but the main way that it is obtained is through cinnabar ore. And the main exporters of almost 50% of the world's mercury are Spain and Italy. Now, some of the common uses are thermometers, HgCl2, which is mercurous chloride. Now, mercurous chloride is a poisonous salt that was used to disinfect wounds. Another use of it is in mercuric chloride. Now, mercuric chloride was a disinfectant used to kill bacteria, and it was highly poisonous. Some other uses of it were mercuric sulfide, which was used to make the paint color vermilion, and mercuric oxide used in mercury batteries. Okay, now mercury is highly poisonous. It's very bad. If it's even absorbed through your skin, or you breathe it in, or you eat it, it could probably kill you. Now we have a sample of mercury. Now luckily this isn't a real sample, so I can do this.
Wait, that was real!
Oh!
I think we're having some technical difficulties. How about it's time for a quick commercial break?
Do you have a serious lack of magnetic properties? Do you have a small number of valence electrons? Can you hardly form any compounds? In other words, are you this guy? You don't have to be. Nonmetals such as helium are no fun at all. You should become a transition metal instead. Transition metals such as myself have it all. With a large number of valence electrons and the ability to form many compounds, why wouldn't you want to be like me? I'm even magnetic. The choice is up to you. Do you want to be an unhappy, dull non-metal, or a lustrous, exciting transition metal? Make the change now.
Now we're going to talk about silver and gold. They're both precious metals and they're both really valuable. First we're going to talk about gold. Its atomic symbol comes from the Latin word aurum. And its atomic number is 79, which means it has 79 protons, 118 neutrons, and 79 electrons. It has many uses, such as being used in coins, jewelry. It's often an alloy, and when it's pure, it's really soft, and it doesn't tarnish. And a carat is the purity of gold to alloy ratio. Now we're going to talk about silver. Its atomic symbol comes from the Latin word argentum, which just means silver in Latin. And its atomic number is 47, which means it has 47 protons, 60 neutrons, and 47 electrons. And an alloy of it is sterling silver, and that's really expensive stuff used in jewelry. Okay, some of its uses are this: the best known heat conductor. It's used to develop photos. It's used in solar mirrors, and it seeds clouds, create rain. It's also used in coins and jewelry. Okay, now we're going to talk about copper. Its atomic symbol comes from the Latin word cuprum, and its atomic number is 29, which means it has 29 protons, 34 neutrons, and 29 electrons. It's second to silver in conductivity. It's found in ores. It's easy to mine. It's used in coins, but it's too soft to be used when it's pure. It's used to make water pipes. It forms bronze and brass. It can be used in electroplating and wiring. Now we're going to talk about iron. Its atomic symbol comes from the Latin word ferrum. Its atomic number is 26, which means it has 26 protons, 29 neutrons, and 26 electrons. It's the cheapest and most abundant of all metals. It's used to make steel, it's used to make a lot of other things. And some of the compounds it forms are Fe2O3, which is mineral hematite, and Fe04, which is magnetite.